Example number 4, I'm going to solve it 3 different ways. I'm going to start with solving through net work. If we have a frictionless surface, then the only force working here is going to be force of gravity, and that force of gravity is at 60 degrees to the displacement. Why am I saying 60 degrees if this is 30? This angle is 30 degrees. That's the direction of displacement, so the angle between the force and displacement is actually 60 degrees. I'm going to solve for work, which is work net, which is equal to work of force of gravity, because normal force does 0 work because it's at 90 degrees to displacement. That will be force of gravity being 2.5 times 9.8, which is 24.5. So 24.5 is the force, times displacement, which is given to us as 5 meters, and then times cosine of 60 degrees. So that's going to be 24.5 times 2.5, gets me 61.25, 61.25 joules of work done by force of gravity as it drags this box down this frictionless 5-meter incline. That is work net. It equals kinetic energy final. Another way I could have found that work net was to find the parallel part of the force, which is this right here. This is mg sine of 30, which happens to be 24.5 divided by 2, 12.25, 12.25 newtons. That's the parallel component, parallel to the displacement. And then I would multiply that by 5, no cosines needed, and then 12.25 times 5 turns out to be 61.25 joules. Boom. So I just solved it twice using parallel component of the force and using the actual force times the displacement, cosine of the angle between the force and the displacement. Gets us 61.25 joules every time. And then remember how we can now use mgh, which is potential energy gravitational at the beginning. This height right here can be found as 5 sine of 30, which is 2.5. How fun. Then force of gravity being 24.5. Here's our mg. Height being 2.5 h. What do you know? 61.25 joules of initial gravitational energy. And then as it slides down, gravitational energy turns into kinetic energy final. Boom. And then to figure out the V final, we do the root of 2 kinetic energies finals divided by mass. In our case, that's going to be 2 times 61.25 divided by 2.5. Guess me 7 is 7 meters per second. There you go.